hello everyone, welcome back to Atomic Ascent, your go-to destination for mastering chemistry with clarity and confidence. If you are preparing for JEE Main or just aiming to strengthen your chemistry basics, you are in perfect place. Today we are starting where we have left last time. So we are going to do 11th question of JEE Main 2025 from class 11 chapter 1 some basic concepts of chemistry. Alright, let's begin. This question states that consider the following reaction occurring in the blast furnace. So in blast furnace, there is a reaction which is happening. What is happening over there? There is Fe3O4. This is a double oxide. As we know, we have studied it in class 10th also. Fe3O4 is actually FeO and Fe2O3. So it's ferrous oxide and ferric oxide in a mixture. So it's a mixture of ferrous and ferric oxide. And it is reacting with 4 moles of carbon monoxide, which gives 3 moles of iron and 4 moles of carbon dioxide gas. X kilograms of iron is produced when 2.32 into 10 to the power 3 kilogram of ferric double oxide and 2.8 into 10 raised to power 2 kilogram carbon monoxide are brought together in the furnace. The value of X, we have to calculate this value. We have been given a few things. The molar mass of Fe3O4 is 232 grams per mole. Molar mass of carbon monoxide is 28 grams per mole. And molar mass of iron is 56 gram per mole. If we have to calculate this X kilogram of iron, first we have to understand that what is the molar ratio of this reaction in a balanced chemical equation. So as we can see that 1 mole of Fe3O4 are actually reacting with 4 moles of carbon monoxide to form 3 moles of iron. So we are only related to this much. We do not need carbon dioxide over here. We have to see that the values which have been given to us, which one is a limiting reagent. Okay, that's how we can calculate the mass of a product. Okay, fine. What we have to do is, whatever we have been given, just convert it into number of moles. So the mass of, or you can write it down, given mass of Fe3O4 is 2.32 into 10 to the power 3 kilograms, and given mass of CO is 2.8 into 10 to the power negative 2, not negative 2, but 2 kilogram. Right? Now, convert these into number of moles. Okay, we are going to convert it into the number of moles. So, number of moles of Fe3O4 is given mass divided by molar mass. So, given mass is 2.32 10 raised to power 3 divided by molar mass has been given 232 grams. 232 grams. Now remember, this value is kilogram So we have to convert it into grams once again. So 2.302 divided by 232 multiplied by 10 raised to power 3, which was already given, and 1 kilo is equal to 10 raised to power 3, right? This is going to come into moles. Now kilogram is converted into grams, and we solve it. We can multiply these both numbers with each other. That is 1000 multiplied by 2.32. It becomes 2320 into this 10 raised to power 3 is 1000 and divided by 232 only. When we take, there is a common factor, that is 232, and it is 10. It becomes 10,000 moles. Now let's find out the number of moles of carbon monoxide. Number of moles of carbon monoxide, once again given mass divided by molar mass. Given mass is 2.8 into 10 to the power 2, and this is once again kilogram, so we had to convert it into grams, and the molar mass of carbon monoxide is 28. So when we convert it, it becomes 280. We are multiplying these two. 10 raised to power 3 divided by 28. 28 is a common factor over here, and it becomes once again 10,000 moles. Now, according to balanced chemical equation, 1 mole of Fe3O4 reacts with 4 moles of carbon monoxide. So according to this, if it is in the power of 10 raised to power 4, then 10,000 moles of Fe3O4 reacts with 40,000 moles of carbon monoxide. So it should be like this. And we can see that carbon monoxide number of moles are given less. So carbon monoxide is a limiting reagent. Okay. If carbon monoxide is a limiting reagent, then the mass of iron, which is a product, will depends upon the quantity which is in which limiting reagent is given. So if there were 4 moles of carbon monoxide, they actually produced 3 moles of iron, right? If 1 mole of carbon monoxide was given, then it should produce 3/4 mole of iron. And if there is 10,000 moles of carbon monoxide, then it is going to be 3 divided by 4 multiplied by 10,000. So if we convert it and calculate, that is 2,500, and that becomes equal to 3 multiplied by 2,500 is equal to 7,500 moles. Okay, we are talking about moles of iron right now. So now we can convert this number of moles into mass. So 1 mole of iron weighs 56 gram, right? So 7,500 moles of iron will weigh 7,500 multiplied by 56, and that is going to be equal to 4200 and once again 0. So it will be 4,20,000 grams. But in question it has been asked in kilograms, so we can convert it into kilograms. So obviously it becomes 420 kilograms. When we look it over here, we can see that it is asked in nearest integer, right? And it is asked in kilograms once again. So its answer will be 420 kilograms. So that's how you are going to calculate this kind of question. Whenever there is a question related to limiting reagent, first you have to find out that what is the limiting reagent. And that's all for today's session, where we have solved question number 11 from JEE Main 2025 from chapter 1, some basics concepts of chemistry. And I'll see you in the next video. Thank you for watching. Stay curious, keep practicing. Until then, keep ascending.